Well, some of it's natural. As I mentioned, you're exposed to radiation all the time. 24 hours a day, 365 days a year. A lot of it comes from radon gas that comes up from the ground, and you breathe that. Some of it comes from outer space, cosmic radiation. Some of it from medical treatments. Some from consumer products. And because we have nuclear power in this country, you get a one whopping millirem per year. On average, about 1 millirem per day, or about 360 per year. And that's average. It could be plus or minus 100, depending on where you live. Because if you live in a place like Texas, you have less terrestrial, you're at sea level, so you have less cosmic radiation, as opposed to living in Colorado, which has more natural uranium in the soil, and it's also at higher elevation, and therefore higher exposure. Now, there's no reason to move from Colorado to Texas just because of the radiation. We're still talking about really low levels. Yes?
Do higher latitudes get more cosmic radiation because of the magnetic field?
To higher latitudes, so as we head north, do we get more exposure to radiation because of the change in magnetism? I do not.
That's where you get the aurora.
Right. So the aurora effect is a whole different type of radiation. But no, I don't believe it makes any difference. Altitude makes a difference. So as you go up in altitude, you'll have higher exposure. But where you are in the world, no.
Well, if you have 24 hours of sunlight, that can make a difference, right?
Well, is sunlight ionizing? It's not ionizing radiation. It's not harmful to us. You might get more of a tan, get a sunburn, but that's a different type of biological effect. But no, sunlight's not going to affect it. Solar flares are a different issue. That's a different type of radiation. We're not going to get into that. It's not really considered nuclear radiation per se. There are a lot of artificial sources that are man-made for different purposes. A lot of them for good purposes, mostly for good purposes. A lot of medical devices, iodine, cobalt, cesium. We talked about radium as a luminescence source. Smoke detectors use americium-241 as part of its ability to detect the smoke is because of the radioactivity. There are all types of devices that use radioactive materials. Some very small amounts, some deadly amounts. Depends on the device and the use. So the big, I would say, most common three are pharmaceuticals, which are being made every day, shipped through FedEx and UPS every day, all over the country, to different clinics for medical treatments. Some of these are very radioactive, very short half-lives, but there's small quantities, and they're controlled. They come in robust containers and such that the exposure is pretty minimal. The nuclear density gauge I mentioned before, this is something that has cesium source that emits gamma. It also has a neutron source emitting neutrons. And these devices are used at construction sites to test the compaction of the density of the earth, the compaction of the earth, and also soil moisture. It's all to meet engineering specifications before they build a road bed, put in a substructure of a building and such. And there's thousands of these all over the country.
I've seen several of those at scrap yards.
They do end up in scrap yards.
People that stole them took them apart to try to pull out the coppers and the other stuff. They never found the source to it. Those are the highest readings I've ever seen.
Yeah, so these do get stolen. They're supposed to be locked under 3 locks at all times, but some people don't follow the rules diligently, and people tear them apart. They don't understand that they're radioactive. The sources are very, very small. They're, an inch by a quarter inch in size. They're very, and you wouldn't even know unless you're in the know. And then you have radiography cameras. These devices have deadly amounts of, or potentially deadly amounts of radiation. And you can see this cable right here, the very end of the cable, that's the source. 1/2 inch by 1/4 inch diameter. That can hold 100 curies of a material, of cobalt-60, for example, high energy gamma radiation. And these devices are very controlled, and they have a heavy containment system that this gets put into, and much higher regulations on who uses them and where and such. So let's talk about a little more about the medical. We talked about the treatment for thyroid cancer, but there's other treatments for cancer using cobalt-60, strontium-90, different devices. Thyroid imaging uses iodine-131. Heart stress test uses something called thallium-201. And in bone, in heart tests, typically use technetium-99 meta. These are all controlled amounts, very high activity, low, short half-life. And you're weighing the benefit of doing the test, having a little bit of exposure, versus not understanding what's going on with your biology and potentially having bigger effects. A lot of commercial materials. I mentioned smoke detectors. Anyone have Fiestaware at their house? This is the older Fiestaware, made in the 50s and 60s. It has uranium in it, in the glaze. They're radioactive. The old Big Ben clocks that glow in the dark, and the dials and the hands here, uses radium. And even no salt has higher levels of potassium-40, naturally occurring material. It's radioactive. These are not harmful to you in small amounts and not worrisome, but they're out there. There's exit signs, not much unlike what we have in the back of the room here. Now, exit signs are either powered by electricity, or they have tritium, which will fluoresce. And some of these exit signs have whopping 10,000 curies of tritium. And there's all kinds of other processes that use chemicals that have reactive materials. The old lantern mantles you can't buy anymore, for the most part, have thorium in them, which is radioactive. So a lot of different materials out there. Of course, there's nuclear waste, nuclear fuel. You're talking getting to more higher levels of radioactivity. Those are all highly controlled, of course. And when you go to an incident or you're dealing with an investigation, a cleanup, really what you need to be concerned about is the difference between what's called discrete source and dispersed source. Discrete is something that's contained or intact, much easier to handle and deal with. Dispersed is when material has been released. And remember, these are liquid, solids, and gases, and once they get out in the environment, they can travel. And that's contamination, and much more difficult to deal with. So where do you find radioactive materials? Well, there are hospital, clinics, biotech firms, a lot of industrial facilities, food processing plants. Someone asked, what type of radiation is used to irradiate food, to kill microbes? It's gamma radiation. Those facilities have sources that will kill you within minutes. Very, very, very high, talking tens of thousands of curies. The buildings they're located in are highly secure. To get to the source, you have to go through literally a maze of hallways and multiple security doors to get to it. No one ever comes in contact with the source. It's always highly shielded and robotically moved from one location to another. But they use whopping amounts of radiation. Transfer stations, landfills, people throw all kinds of stuff out in the garbage. Every landfill in this country has a radioactive source in it. Might be very low amounts, but they're there. Then, of course, military installations, you can find them. Abandoned waste sites, you find radioactive materials. They're everywhere. So let's talk about some signs and labels that you may come across. First of all, this is the fallout shelter symbol. Does not mean you have radiation. This is the atomic symbol. Does not mean you necessarily have radiation. The only recognized symbol internationally used is this symbol here. The trifoil, it's either magenta with a yellow background, it can be black and white, red and white, whatever. It doesn't matter. It's the symbol that really counts. And that's a symbol that something is radioactive. There's all different types of signs and labels. And we're not going to get into the regulatory aspects, but there are regulatory reasons for why you have to use certain ones versus the other. Some of the more common ones you may see if you go do an inspection at a facility could be these. Caution, radiation area. By law, if a material emits more than 5 millirems per hour at 1 foot away, you have to have this sign. Okay, we're talking licensed material here. Should be a controlled facility, security, only authorized personnel allowed to be around the source, and so on. High radiation area, you're over 100 millirems per hour. Again, not deadly amounts, but cause for pause. If you see airborne reactivity area, you better be wearing a respirator. And then the old ubiquitous caution reactive material is applied to certain quantities that meet regulatory conditions, and others that don't require that may just have the old radioactive material. It's limited quantity, much like these do here. Got the little trifoil on here, just saying, alerting someone that it is a radioactive material. So let's talk about decontamination. This is always a big concern if you're going to play in this game is, how do you decon? Well, let's look at this little video here. You'll learn everything you need to know about decontamination right here. We need sound. We have no sound. I guess we should have tested this before. I got it there. Oh, you know what? I know why, because I turned the sound off.
I love working with that big guy.
Keep the doors coming, Charlie. I'm on a roll today.
George and I are like brothers. 2319! We have a 2319!
George Sanderson, please remain motionless. Prepare for decontamination.
Duck and cover, people! Oh, not the CDA.
Clear the contaminated area. Into the 2319 rocket. The area clear. Coming through. Watch yourself.
External contamination.
Stand back. Careful. All clear. Situation is 990. Ready for decon.
Hey, thanks, guys. That was a close one.
Okay.
Okay, people, take a break. We got to shut down for a half hour and reset the system.
Any questions? It's pretty simple. Actually, when it comes to decontamination for radioactive contamination, we try not to use water, because water creates waste that radioactive waste is expensive to get rid of. You can spend thousands of dollars for a drum of waste, liquid waste. So we tend to limit the amount of water. If our clothing or gear is contaminated, we try to wipe it off. If we have to cut a piece of the material out of the PPE, the protective coverall, your clothing, that's what we'll do, and isolate just the radioactive contaminated part. We do, however, use our instrumentation to determine whether you're contaminated, and this is the great thing about radioactive materials. For biological, chemical, there's not an instrument that can scan and see if you're contaminated. But with this, you can. And it's very, very sensitive. And so what we call frisking, I use this detector and move it over my body very slowly, and I can detect whether I have contamination on me, on equipment, on any surface. So a very easy way to determine whether I'm contaminated. And so we use the pancake probe. It's the most common tool used for our decontamination process. It's a small detector, but it's sensitive, and it does alpha, beta, and gamma. Now think about the detector, because it is so small, to frisk an entire person from head to toe 100%, it would take you over half an hour, because you have to move it very slowly, about an inch or so per second. So we tend to focus on areas that are the most contaminated. And the areas you're most contaminated, obviously, are your feet, your hands, your face, thighs, because you tend to wipe your hands off on your thighs. Sometimes your butt, because you rub up against stuff as you're moving around. Those are the areas we focus on. And then we can give a cursory look-see in the other areas. But it really should take about 5 minutes to 5 or 10 minutes to frisk someone out properly. Decontamination solutions. Soap and water is best for people. We don't want to abrade the skin. This is not like the movie Silkwood, where Meryl Streep is put into very hot water and scrubbed with these brushes that will break the skin and drive the contamination in. Just mild soap and water, no aggressive scrubbing. If we have to, we'll repeat this several times. Now, equipment, we can get a little more aggressive, and we have found things like scrub and bubbles or spray and wash very effective at decontamination equipment. So this little video is an investigation I was performing at an old abandoned landfill in Sonoma County, and I had just finished checking out one of the radioactive sources we had. And so I'm being frisked to see if I got contaminated.
My freaking hands now.
Yeah, it is.
We have contamination on the PPE here.
It's on your index finger primarily.
Ooh, yeah.
It does go to 10 times.
Wow.
Way to go.
You can't see, smell, taste, feel radiation, but you can detect it really easily. I had no idea those gloves were contaminated, but they were highly contaminated. And so I took them off and put a new pair on. Pretty easy. But you don't know until you use a detector to determine. So let's talk about radiation risk. There's a lot of activities you do that are risky every day, whether you believe it or not. And so I want to kind of put things in perspective. As I mentioned, I'm a trained chemist, feel pretty comfortable working with chemicals, but hands down, give me radiation site incident any day. It's way, way easier to deal with because radiation is well characterized. I've just taught you basically everything there is to know about radiation. It's very easy to detect with simple instrumentation, very low quantities, and then you can protect yourself. And they're predictable. Temperature, pressure, weather, nothing's going to change the fact that something is radioactive. So what single instrument would be best to use to conduct an initial survey of an area? That's a little bit tough question. We don't go into instrumentation in this class heavily, but there are really, you need 3 basic instruments to play in this game. You need the pancake probe, which we've talked about, because that's to determine whether you're contaminated. But see, this does not tell you what exposure is. You wouldn't walk into an incident holding your pancake probe out. It's not a very good gamma detector. In fact, it's a really crappy gamma detector. It's pretty good for beta. It's okay for alpha, but it's terrible for gamma. And that's the one I'm most concerned about because it travels further in air. It's what's going to bite me first. So I need what's called a sodium iodide detector. This one's quite large, actually. They make them smaller, but this is very sensitive to gamma. And this will give me my exposure rate, that micro Rankine per hour, milli Rankine per hour. So I have to have this type of detector also. And then I showed the example of the yellow dosimeter, the real time. I need one of those because I want to know real time what my cumulative dose is. So those are the 3 basic ones. When I go into an incident, I'm going to have the sodium iodide for gamma, and I'm going to have the dosimeter. When I come through decon, I've got the pancake probe. So to answer your question, it's really 2. It's the dose rate meter and then the dosimeter are the 2 basic ones. Now, there are instances where if you're looking for contamination, that's your objective, then you would bring this in at the same time. So you'd end up with 3 different instruments. Now, sometimes you can combine instruments like that dosimeter I showed you. It does dose and exposure rate at the same time. So then I may end up with 2. So it really depends on what you're dealing with. This is an alpha detector. It detects only alpha. It's got a big wide face here. It's used for looking at contamination on surfaces, but it's limited to just alpha. And you'd have to know you're looking for alpha. And it's really just for contamination on surfaces. So it all depends on what you're doing. But the general rule of thumb is you need to have the dosimeter, and you need to have something that detects the gamma, give you your exposure rate. So relative risk, 1 in a million chance of dying from the following activities. Okay, 1 in a million chance of dying from smoking about 1.5 cigarettes because of lung cancer. So 1 in a million chance you'll die from staying in New York City for 2 days. Not from a mugging or getting shot, but from the air pollution. Canoeing for 6 minutes because of drowning. We're obviously a country of really bad canoers. Driving 40 miles. This is probably the most hazardous thing you do on a daily basis, drive your car. Drive 40 miles, there's a 1 in a million chance you'll die from an accident. Eating 100 charcoal steaks, and not all at one time, but cumulative because of the PAHs, which are carcinogens. Yeah, that's true. That's a different story. Flying an airplane, if you go in altitude, higher levels of cosmic radiation. Flying from here to New York, you're going to get, a millirem or 2. Or receiving 2 millirems of radiation, increased chance of cancer, 1 in a million chance. So you think about all the things you do on a daily basis, they're risky. Radiation is just one of them. And we try to reduce our exposure as much as we can. Another way of looking at it is, lifestyle. Smoking, huge hazard to our health. Takes years off our life. Obesity, alcohol, home accidents, 5 rem per year exposure reduce your life by 32 days compared to all these other things. I'm not trying to minimize the risk of radiation, but you gotta balance it with everything else in life. And I don't want you to overreact or underreact to radiation, but realize it's very easy to deal with, and you can protect yourself. A lot of things you can't, or are much more difficult. If you have an actual incident or a facility or a site that has a radiological component and you need additional help, who do you call? Well, maybe within your organization, you've got a hazmat team, environmental health, a risk management department that has resources. Within the state of California, we got Cal EMA, who I mentioned before. We have the Radiologic Health Branch. They're part of public health. They have numerous health physicists who are very knowledgeable of dealing with and handling radioactive materials. We have the Civil Support Team, which is a military group, highly trained in all types of hazards. On the federal level, the EPA, Department of Energy, and Department of Defense have almost infinite number of resources. I should take that back. I want to say infinite. A lot of resources. Here in California, your main call is going to be to Cal EMA. They can get you in touch with the Radiologic Health Branch. On the federal level, it's the National Response Center. They have a 24-hour number, and that dispatches into EPA and Department of Energy are the majority response agencies. Department of Defense only gets involved in nuclear weapons issues for the most part. If you want to reach the federal EPA, the sponsors of this class, you can call EPA directly 24 hours a day, and they can dispatch resources, like myself as one of their contractors. The Radiologic Health Branch for California State is based in Sacramento. They also have field offices throughout the state. I don't know, I think some of these may have been closed recently, but here are all the phone numbers, and they're open during business hours. But again, very knowledgeable people available to assist you. The federal level, there's really a tremendous amount of resources. The EPA, we've got 4 different special teams that can assist throughout the United States. The Department of Energy really has most of the assets in this country. And they've got a whole range of different groups that have various objectives and types of equipment, thousands of different types of detectors and hundreds of very well-trained personnel. So a quick review of what we've discussed today. We talked about alpha. Is alpha external hazard? No. Internal hazard? Big time. Beta, external hazard? Probably the most severe exposures, you get the contamination on your skin. Beta will do a lot of damage to your skin. Of course, internal hazard also. Gamma, external hazard? Yes. Internal? Yes. X-rays, not nuclear radiation, but just like gamma, they're hazardous. And then neutrons. Obviously, internal, external hazard, but very rare. We talked about how to measure the amount of radiation. That's the Curies and Becquerel. Becquerel being international units. Remember, that's the amount of radioactivity, the amount of radiation emitted from a material, not the measure of the mass or the quantity. Then we had the exposure rate, micro Rankine per hour. You know, one thing, a lot of people see that R and they say rem. Micro Rankine, micro rem, it's basically the same thing for all practical purposes. Don't get hung up on the terminology. I don't care if you call it Rankine or rem. Technically, it's a Rankine. That's the exposure rate, the amount of radiation coming at us. The amount of damage to our bodies is measured in rem or sieverts. Now remember that there's 100 rems in 1 sievert. Then the difference between internal versus external contamination. Hopefully hopefully we're not contaminated, but if we are, it's external. We can wipe it off or remove the clothing to get away from it. Internally, a lot more difficult to deal with. The difference between contamination and exposure. You're exposed to radioactive material if you're near it and the radiation is coming at you. You're contaminated when you get the material on you or in you. And then the way we protect ourselves, time, reduce the time, increase our distance, and increase shielding, if that's even possible. And I love Gary Larson, and he's got this great cartoon. And if you don't get it, I'll probably be teaching this class next year or a different conference, and you can always repeat. And that ends our formal lecture.